All right, I want to switch over to emergence, or true emergence, not re-emergence. And Peter, you just having come back from a relevant conference, can you give us a little bit of an overview of, where people in this field see sort of the biggest threat at the moment? And the other thing that I wanted to ask you is, do you feel it's socially / politically more difficult to get an audience for this kind of topic, as opposed to, because the drug-resistant emergence, that's something that affects us immediately and affects us all. That one spillover event that will, kick off the next HIV pandemic, that seems very distant.
Well, I'm going to take that second question first, because I was quite intrigued by this. So I've just been to Australia, and Australia's obviously a developed country, and they have, and it's from New Zealand, hence the coughing. But in Australia, there's been these serious spillovers of Hendra virus taking place, and Hendra virus is basically circulating in flying foxes. And then it's been spilling over, or we thought it had only recently spilled over, we think it's been taking place for longer than that, into the horse population. The horses get very sick, vets, the owners of the horses, go to the horses, then they become infected, then they die. So we've seen something like 48 outbreaks of this in northern Australia into horses, and something like 19 deaths in humans, that sort of level. So it's not huge, but it is taking place in a developed country. And if we can't do anything about it, then that is really shocking. And so part of this meeting was to bring everybody together, to bring the social scientists, the virologists, the ecologists, the bat people, the horse people together to try and find a solution. And I think, I feel positive that we could find a solution. But there's a lot more research that's actually needed in that part of the country to understand what's happening, not just with that virus, but with the whole family of henipaviruses that occur in the flying foxes and many other issues that were sort of raised. But the political side was, we've developed a vaccine. This sort of works in the horses. Nobody's using it in the horses because it's so expensive. So it's not, the take-up is not good, but the political answer is we have a vaccine, therefore it's sorted. And I don't think that's the right answer at all. I think there are going to be other problems come about. And of course, what the government wanted to do is that they just wanted to go away. And that's always the political issue. As long as it doesn't come again in my period in government, then that's okay. We can leave it for the next poor people to do. So there are some major political issues with this. But this isn't unusual for it to come from wildlife via some other host, sometimes some other peri-domestic host, and then be exposed to humans.
Right. So, can you maybe pick up the lead here a little bit? I mean, why is it that so many of these diseases actually manage to live in different hosts?
So the agents live in different hosts.
Yeah, the agents.
There are.
Didn't you watch that?
How did you watch that video?
I haven't watched it.
It's up there.
Click from here.
Yeah, an interesting question, and I think there's way too many plausible answers for that. But I think this intermediary host with a domestic animal is particularly interesting, because horses play that role a lot. So Venezuelan equine encephalitis is similar, although that's where the big outbreaks come from. So why is it that we don't become, humans don't become infected directly from the species in which in this case, a virus, is typically circulating, and circulating without having any, correct me on this one, but no noticeable effect on the population.
You're right.
Yeah, so you have to actually look before you can make those statements, but we don't see population crashes.
In the bats,
in the
flying
bats,
foxes,
in the bats, and then, similarly in rodent populations that carry some hantaviruses and other types of infections. So this spillover into a peri-domestic, and in this case horses, there are some interesting reasons, and one is that we don't see typically a lot of genetic change in the virus as it moves if you compare what's in the bat and in the horse. But there are some changes that occur that don't affect the genotype, and we call them post-translational modifications. They affect the proteins, and that may be just a little bit of change of the sugar and the proteins of the virus that help the virus gain entry into a human host. There might be something unusual about how horses do that modification that facilitate this type of transmission.
I guess one other possible and interesting issue is that there's A, the issue of susceptibility, but B, also the issue of exposure.
It's proximity.
And for some of these viruses, typically there is a dose response curve, so you do need a decent dose in order to get infected. And probably we very rarely get coughed on, sneezed on by bats and wild rodents, whereas we do have very close proximity to a lot of our companion animals, dogs and
but we don't see a lot of spillovers from dogs. And how many people? Yeah, we need a dog here so everybody could kiss it. But people have a lot of very close contact with their dogs and their cats.
So in this example, there have been 2 dogs that we know have been infected. And one of those dogs was actually sleeping in the bed with one of the daughters, and there was some concern that the dog, which we know was infected, could have transmitted, but it didn't actually pass it on. And I think there is a case for studying this virus more in dogs and to understand what is happening there. But once again, the politics in Australia is that no, we don't actually look at that.
Not just probably, there's just the massive amplification of these viruses in both cases that we're talking about, Venezuelan equine encephalitis and enterovirus.
But of course,
it's just, and when a horse gets sick, the first in the vets, and this is a respiratory infection, it's really possible to aerosolize, a considerable amount of virus. In the case of Venezuelan equine encephalitis, it's a mosquito-borne infection, and there's a lot of surface area on a horse for transmission.
And I thought the story with the flu, with a lot of the avian flus, was that the pig is a big replicating vessel. It brings the doses up high.
Yeah, I hesitate to say that this is just a numbers game all the time. I think that there are some qualitative, features. Yeah. So I think it is really hard to generalize on this. But these intermediary hosts really do seem to play an important role. I think that was also seen in the SARS outbreak. Yeah.
But a lot of those horses could have been exposed but not become infected or not even show disease symptoms.
The early studies, that was a 1995 outbreak, was your first enterovirus, 3, 5, somewhere 45, in there.
4, 5,
so they did tremendous, serological surveys throughout, and there's not.
They didn't.
That's right, in either humans that were bat handlers or in the horses, and so there's not good evidence to suggest that that's the case.
So that's one of the things we discussed. Why is it that people who look after bats don't become infected?
And again, it was the same thing with SARS coronavirus. They're not a higher risk.
And actually, the current hypothesis is that the bats, even though they're stressed when they're in captivity, the type of stress they have is different. So it's the stress that they get associated with when they're searching for food seems to be associated more with the likelihood of spillover taking place. But that's just a hypothesis. That's just a hypothesis. But, if we can't understand this in Australia, in a developed country, what the hell chance do we have for many of the other emerging diseases?
Yeah, this one's just perking along with the number of cases being small, but they don't all do that.
Well, speaking of another developed country, I want to quote you twice, actually. So you have this really interesting statistic.
Are you quoting me back at myself?
Yes. So you said in rich countries no one dies of drug-sensitive cancer cells. If you die from a tumor, it will be filled with cells that have evolved resistance to chemotherapy. And then I think you said something like 500,000 people die of resistance cancer cells.
570,000 a year in America.
In America, and then you said, add to that the 100,000 that die of drug resistance, that adds up to 600,000 in America alone. So millions of people all over the world. And yet, you said it is possible to become a physician in America, and I guess everywhere else too, not believing that evolution happens or not knowing much about how it works.
Yes. That's true.
So,
that's actually been studied a bit. Roger Short did a very nice study in the University of Melbourne with medical students coming into his class. He polled their opinions on evolution on arrival, and then he taught them evolution, and he polled their opinions after they'd done his evolution course. 50% of them were creationists when they arrived, and 50% were creationists when they left. And he made the
other 50?
No, I believe he hadn't actually changed them. And he made the argument that anybody that is in medical school who doesn't believe the evidence for evolution should not be allowed to be at medical school, because if you are taking or leaving the evidence that suits you, what sort of doctor can you be? So he very strongly made the view that that sort of person should not be at medical school. And I think that's an argument, a discussion that we should be having as a society. That if you are picking and choosing evidence to suit your beliefs, as a medic, that seems like a very dangerous thing to be doing.
Right.
I think that there's a couple of other areas, though, that are really coming to play on cancer treatment. And cancer has traditionally been thought of as a clonal proliferation. So you take a cell and you do something to dysregulate it, and then it proliferates. And so, in essence, it's a clone. But they're not. Okay, we need to think about them as populations, and populations that are evolving under natural selection. And so we're going to have quite a diverse population of cancer cells. And so, I actually disagree with your statement in that you likely can have quite a mixture of resistance, because the phenotypes of the cells are going to be really different. And in some circumstances, depending on the environment, selection for metastasis or that metastatic phenotype may be what is most fit in the environment, treatment or not. So I think we need to consider cancer as a very diverse set of cells with each with unique, phenotypes, and not just responding to one specific selection pressure.
Yeah, so I very much agree with your point about range of different cell types. In fact, if you think about how cancer's working, it's a dysregulation process, and as soon as you've got dysregulation...
And multiple.
As soon as you've got dysregulation, then you've got a huge amount of variation on which selection can act. No question. Then it becomes, in fact, an evolutionary problem. If there's no genetic diversity, no variation, you haven't got it.
That's right, and this is where evolution really comes in.
It is an evolutionary process.
Tremendous genetic diversity.
On the resistance case, so what I guess I mean there is that when people are being treated with drugs, anti-cancer drugs, and they fail because of resistance problems.
So I think you've gotten into a conversation on biology when the question was revolving around sociology, and I think that really brings it to the point of whether individual perceptions and beliefs should overcome a collective need. And I think that really gets back to the whole concept of whether you should be vaccinated, or you should or should not take antibiotics for a viral infection. And I think what we have to do as a society is really come down to the decision on when does individual rights trump collective rights. So if a doctor, for whatever reason, has this belief and therefore evolution is cherry picking, I would stand with Andrew and this other author saying that that person shouldn't be allowed to be a practicing scientist, and which is what we expect doctors to be. And simply by having a belief in some supernatural entity which we can't articulate correctly doesn't give you the right or the ability to put in danger other people. And that's the problem. Collectively, we have to think about evolution and a response to evolution in order to maximize the good for the greater number of people.
Yeah, I'm not sure that argument holds in the cancer treatment. Nevertheless, I think that we act as better physicians in treatment if we consider that we are dealing with a highly diverse population, in this case of cells, that are likely to have a variety of different responses. There's good reasons why our treatments fail. And one of the interesting aspects now, I think, with the personalized medicine, and I'm not endorsing this or not, one way or the other, but very simple things with drug resistance, like how quickly a drug is metabolized in your system, does have genetic bases. And so this ability to sort of target an individual so that they're dosed correctly, so that the drug actually can get to the cells where it needs to be taken up. It's something that we're doing a little bit better.
Yeah, I suppose I'd go one stage stronger on this and say that I totally agree with you on that. The personalised medicine side of things and the variation matters a lot. It's not clear to me how one could be a physician in the modern era dealing with infections or cancer or indeed anything else without knowing the fundamentals of evolutionary biology. It's like denying the fundamentals of biochemistry. I mean, it's just crazy. You can't be a physician not believing biochemistry. How could you possibly treat infections and deal with genetic diversity and all the issues that follow from the evolution of resistance and escape and all of that without knowing any of that science? It just makes no sense to me.
Well, having gone through that system, and I can say that I've never had a class in evolutionary biology, I believe in it.
Yeah,
but I certainly there's no training in
and I'd say that would be as bad as my lack of training in biochemistry,
which is pretty bad.
Yeah.
But just to wrap this up, I mean, in the past couple of weeks alone, I think there has been huge press about antibiotic resistance and the potential threat. Do you think that will eventually be accompanied by a change in that attitude? Or is it already changing? I mean, there are all these books about evolution, medicine, and conferences and so on. Especially in the infectious disease domain.
I think amongst the evolution deniers, actually nothing much changes minds. Right. The issue is more amongst the people who are unsure. And there, I think the reality of resistance evolution and the more it affects medicine, your outcome in a hospital or your outcome after your hip transplant, the more people are going to pay attention to it. But amongst the evolution deniers, they draw a line, a distinction between evolution in microbes and drug resistance and the evolution of monkeys and elephants and dinosaurs. Mm-hmm. And, that's just such a bizarre distinction to draw. Yeah. Really crazy to me. Same process.
But just to be clear, I don't think any of us, I would want to make sure that we're not suggesting that you can't have a faith in the divine and believe in evolution. Right, so you can be a physician who encourages people to go get social support and to believe in that kind of divine support and be concerned about how things evolve within a pharmaceutical environment. So I wouldn't want us to collapse all those who believe in the divine into a category of absolutely not believing in evolution in any form. That there's lots of variation and kinds of profiles of beliefs here.
Yeah, I think that's absolutely correct. 10% of the world's population are Catholic, and they're very, very precise in their adoption of evolutionary theory with no problems. I think what we're speaking about here when we're talking about the American context is evangelical Christians who have become creationists over the last 80 or 90 years. We can see this increasing move towards this six-day belief, which necessarily has to throw out an awful lot of evidence, which we have built up ever since the Enlightenment and before. And the loss of this evidence, which is very well established, is terribly problematic, not just for our society, but also it turns out, for the health of individuals being treated in hospitals. So I think you're absolutely correct. There are beliefs which do take on board evolution, and there are some which build themselves around the rejection of evolutionary theory, and it's those which tend to be the most vocal ones.
Yes.
For which we have great problems.
Yes.
I think it's important that people appreciate the work we're talking about here in evolution is the process of natural selection.
Mm-hmm. Yes.
That's what we're really talking about, isn't it? And that's what is important, that they and I think it's important for all science that they understand the process of natural selection. It's common sense.
Yeah.
Many years.